This week, the maiden voyage of Application Security Weekly, episode 0, will follow. We'll be talking about the rise of application security, a brief history of application security, basically why we decided to do this show, which is awesome. Very excited. Our second segment, we're going to cover some news in application security, including, I think the primary news this week is Meltdown and Spectre, some of those CPU bugs in Intel, and some that may even touch AMD architecture, but Keith will have all the details on that for our listeners. In Learning and Tools, Keith got me excited about this SANS Secure DevOps Toolchain poster, which I also want multiple copies for my office and all of our developers as well. So stay tuned. This is the first episode 0 of Application Security Weekly. This is a Security Weekly production. This episode is brought to you by IT Pro TV, binge-worthy learning for IT teams. Why is it binge-worthy? It's learning presented in an engaging and entertaining talk show format that beats voice-over PowerPoint snooze fests. IT Pro TV offers an on-demand course library with more than 3,300 hours of content. Watch on your desktop, on the go, or in the comfort of your own living room. IT Pro TV is IT training you and your team actually want to watch, which means a better return on your learning investment. Get started with IT Pro TV for Teams with a special offer for Security Weekly listeners. Visit itpro.tv/Security Weekly to start a 7-day free trial and get 30% off a standard or premium IT Pro TV membership using the code SW30. Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Welcome, everyone, to episode 0 of Application Security Weekly. 00 even, which is just awesome. I'm so excited to bring this new show on our network. I'm not even really your host. I'm just Paul Sidorian. I'm just here to try and look pretty, I guess. Your host for this episode and all subsequent episodes is none other than Keith Hoodlet. Keith, welcome to the show.
Thank you very much, Paul. Very glad to be here, and very glad to initialize this array of shows here on the Security Weekly Network. I think we're going to have a lot of fun.
Yes, absolutely. I just want to say, first off, I love the logo and the music that came together so nicely. Props, round of applause for our production team for making all that happen. Thank you very much. Keith, of course, what is your title? You work for BugCrowd today. What is your title at BugCrowd?
So I am a trust and security engineer, and what that ultimately means is, being a small company, we do a lot in terms of a little bit of the prospective customer sales side in terms of being a technical trusted resource, some work on the security researcher side in terms of having a fuller understanding of what application security actually looks like today for a lot of our customers as they onboard, and giving them guidance and feedback on how to go ahead and remediate vulnerabilities that are found. But of course, then from there, we do other things like projects, development, making MVPs to hand off to the actual engineering team to then move forward with proper features and so forth. So we do a lot as a trust and security team. And I got to say, it's probably the best team that I've ever worked with.
That's awesome. Keith is a person that I would reach out to in the past and still to this day if I had questions about application development, and specifically questions about security as it relates to application development. And over the course of time talking with Keith, I'm like, we should really do a show on all this, because I would constantly bug Keith about, so when I do Docker and when I do this Node.js thing, how do I do it? How do I structure it? How do I secure it? And Keith always had great answers. And I'm like, this is awesome. You should be the host of a new show. And thankfully, Keith has accepted that position. And there's already some excitement on Twitter. I saw the Twitter kind of a chain go across that people are excited, which was interesting because people request a lot of things of us in terms of new shows. This topic actually wasn't number one, but it's number one in my heart for the new show that I wanted to create, because I feel that developers can benefit from having a more security-oriented message when it comes to development. I also believe that security practitioners today need different and more messaging and education and knowledge on secure development today, as I think there's been some huge shifts. Well, DevOps is like 10 years old, but I feel like just today it's starting to become more and more of a reality and more of the way that many places do business, and moving into a position where everyone will develop this way. Now, that offers some benefits and offers some challenges to security professionals, but I feel it's extremely important and different enough that we need an entire show where we'll do interviews and talk about news as it relates to application security. So I'm excited.
Yeah, I think it's going to be great, especially because for what we see, at least now, right, security engineers are suddenly being tasked with getting involved in the DevOps process. And a lot of people call it DevOpsSec or DevSecOps or what have you. But at the end of the day, really, security needs to be involved in that process in a transparent and in a fluid way, so that they're not disruptive to the process of the company producing features and producing ultimately what makes the business profitable. From there, it's just a matter of helping our listeners, both on the developer side as well as on the security side, being knowledgeable enough to move forward or ask the right questions so that they can actually be a part of that process in a way that is valuable to all sides of the business.
And I really think process is one of the key words there, is those processes that you may know and love or not love and remember in developing applications have changed dramatically. There's a lot more options today. That what's exciting for me is it makes your life better as a developer, and it allows for security to be built in and become part of the process in just a way, even in the way that you can push code faster than ever before and push out new releases faster than ever before. Even in just that one aspect, I'm like, this is fantastic. I mean, there are projects that I want to work on that really I'm like, if I can just push out new code and new releases more quickly, it's worth whatever time investment I have to put into that project to make it happen. And so you've got some articles in there on the history of application security. I don't know if you want to start, Keith, by talking about and I think one of the fundamental things in kind of talking points is that transition from traditional waterfall development to DevOps. And so and then we also had Agile, which was kind of in between. Maybe a good starting point for me and our audience would be to describe waterfall development, Agile development, and DevOps in like a condensed, like just set the foundation, because those are terms we're going to use in the show probably quite a bit.
Yeah. So in terms of waterfall development is a simple process where you have long periods of development and planning that lead to maybe one or two releases in the course of a year. So ultimately, it goes through kind of a significant planning process out front in terms of the features that you want to develop and maybe the greenfield product that you want to produce, going into then all sorts of review as to how you're going to build it, what languages you're going to use, what sort of architectures it's going to be built on or supporting. And then it goes through a slow development cycle where it is finally released maybe at the end of 6 months to a year. And that is traditionally what a lot of companies would do. I mean, if you look at companies like Oracle or even Microsoft, where we're going to push Windows 95, and then we're going to push Windows XP a few years later, and then we're going to push, and so on and so on. It's a slow development process, and perhaps careful, which is nice to the extent that you can actually have a stage as part of that development that fits security very nicely and very cleanly, and may be able to push back the actual release cycle a little bit, but to the extent that it's not, it actually has a place in that waterfall lifestyle. Whereas moving into Agile, the whole idea of Agile is to move quickly, to be agile. I mean, it's right in the name. And so it's a matter of iteratively working through development in small pieces, but in ways that allow you to almost put the rails down on the track as the train is moving forward. Mm-hmm. So that way you have a constant style of release, you have a constant set of features that are planned and being worked on, Usually they use something called sprints. So you have like a 2-week cycle of development.
They're like it sounds like Agile's like mini waterfalls.
Yep. Yeah, that's the best way to put it. And the thing that's different about Agile and DevOps in particular is that with Agile or with DevOps, you can push code to production multiple times a day. And so to that end, it's a little bit scary for the security folks because let's face it, if you've got developers pushing code to production multiple times a day, there's no time for security to actually say, hey, wait a minute, we need you to stop so that we can do this all appropriately. And so for a lot of organizations, and especially a lot of companies that have come about in the last 10 or 15 years, and especially in the security space, are trying to move left or shift left is what everybody calls it, which is move to the very beginning of that software development lifecycle, help with the code scanning and review of the actual development or process of development as early as possible and as often as possible so that you can go ahead and push things to production in a mostly secure fashion. The benefits to this is that, of course, you have things like continuous integration and continuous development tooling. So things like Jenkins or Travis CI. We'll go into the detail on those, I'm sure, in a future show. But again, it's just a matter of pushing code quickly so that you can get out and get that kind of first mover's advantage when any feature or product is released so that ultimately your business can be profitable. So,
well, and that is one of the major differences between Agile and DevOps is you're not just pushing out new code, but you're pushing out the entire architecture over and over again. I think that's what really helped us enable the DevOps mindset was having containers, microservices, and those such things that you're not just rolling out new code. You can roll out essentially entirely new full suite of applications that include the operating system, the configuration, the application servers or any other services you require, and your code kind of all in one shot broken out into multiple different microsegments, essentially, right?
Yeah, and to the extent that, that's something that's new within just the last few years for that matter. So if you think about it, maybe 5 or 7 years ago, there, give or take, you would have like AWS instances as microservice instances where you would just be able to like spin up a new image of maybe your website or what have you if there was issues in the current iteration of that product or feature. And so the whole idea or the whole concept of now being able to go a step further and actually have entire architecture in the form of, say, Docker containers that you can just simply spin up and replace in line. There's very little to no downtime experienced. And if there is downtime at all, it's maybe in the microseconds range, right? Like nobody notices that there was a shift over from this one feature set to a new feature set unless there was major overhauls to the actual like UI UX. But yeah, it's a whole new world of both containerization, the whole idea of APIs and microservices now, where you have certain containers or certain features or functionality of the application that is intended to speak only to other sections of the application, but that they live all separately. They're not monolithic anymore. Things are broken down into very small pieces.
While we're on some of these foundational topics, Keith, the scariest question that I think I've ever gotten in recent times from a developer is I was describing regression testing, and they're like, "What's regression testing?" And I was like, "Whoa, boy." Oh, boy. Not just so how does that relate to producing code in applications with integrity that perform well, that have less bugs, right? Those are the like foundational elements of producing software. But also, how does regression testing play into security as well? And what is so start with what is regression testing for our audience, because it's so important.
So when I was at Veracode, for example, I worked in the QA team for the binary static analysis tool. And so regression testing was more or less my task, is identifying regressions and then making sure that we remediated those regressions accordingly. And what that is it's basically you have an expected state of the application or the feature or the product, and functionality within that product regresses, meaning it actually breaks in some way or doesn't work as intended. And ultimately what you want to have is you want to have the code that you're introducing allow the application to work in the same intended ways as it was initially working, and then have that additional feature set added onto it. So to the extent that a developer might not understand what regression testing is today, isn't such a bad thing if you look at kind of modern developments or modern ideas, right? So there's test-driven development, which is you build a test to fail, and you build a test to fail purposefully. You then go write the code so that the test will pass, and you do that iteratively where you're always building a set of tests first and building out the code to make those tests pass as you work through the development of the product. And so to that end, you should, in theory, never have regression because you're always testing before the feature actually pushes live. The other side of that may, of course, lead to a developer not knowing about regression testing is the whole idea of continuous integration or continuous development, where if you have a build that is being produced as a result of code being pushed to like a GitHub repository or what have you, and it's making sure that all of the tests, or in this case, regression tests, for lack of a better term, pass, in some cases that's security scanning as well, then that build can get pushed to production accordingly. And if a developer is never actually basically they followed all of the rules of development with the organization that they were working with, that they never had a build break, they might not understand the whole concept of regression testing because they're doing it live effectively.
Yeah. Well, and I think in any model, it's important that when it's not just with features, but with bug fixes as well, that those get pushed into a system that I may have changed one part of the application. It could have been something as simple as a bug fix, and it could have been a very simple bug fix, but it's important that that application goes into a QA environment and all of the other features of that application are tested to make sure they still work. And that's kind of how I think of regression testing is as more complexity is introduced in your application, more dependencies could be there, and you may not know what could break without some kind of automated testing inside of your application. So I may make a bug fix in one area, not realizing that there was some code that relied on that is now broken. And my bug fix and it worked, but I didn't test that other piece of functionality to make sure that it still worked. And that, is and normally we would do, I feel like in waterfall development, regression testing was something that was done every once in a while. Like we'd fix a bunch of bugs, put in a lot of new features, and just kind of keep going, and then go, oh, by the way, we got to go back and do some regression testing, and then have a whole bunch of new bugs. What Keith, you're describing is we keep moving forward, right? We're making changes. Those are automatically happening on the fly. I like your analogy of as the tracks are being laid down, we're continuing to build.
And I think that a lot of people today, especially developers, would notice this to be something like unit tests and integration tests, right? Regression testing, it traditionally was you build, like you said, a whole set of features or a whole bunch of bug fixes. You put it into the code to make sure everything still works. Usually it's a very manual process where the actual QA team will go about making sure that the tests pass. That's effectively what I did at Veracode. But now what you actually see is you have a unit test which makes sure that the piece of code that I have written works as intended. And then you have an integration test or a suite of integration tests that make sure the piece of code I've written doesn't break anything else in the code base. And those are usually run as part of a continuous integration model, whereby you push the code up to a repository. It then tries to build that code out as part of the entire product or feature set. And then from there, it will go ahead and say, okay, yeah, there's nothing that's broken according to all of the unit tests for all of the other pieces of code, and of course, all of the integration tests accordingly. The interesting thing, and I talk about this a little bit in one of my talks that I give on attack-driven development, is the whole concept of, well, if I have a lock on a door and I test that the lock functions appropriately, I can close and open the lock, and the door still functions where it can open and close, the security side of this is, does the door open when the lock is closed? And a lot of the time, development doesn't think that way, which is, I think, part of the benefits of the show is making sure that when you're writing unit tests and integration tests, that if you have features that are intended to be security features in some fashion, you're testing that those are also working appropriately in terms of the failure state works appropriately as well as the open state.
Keith, you've got some great articles in here on, the first one is the history of application security, which is, it's interesting, is the second time in the past couple of weeks we've mentioned Rainforest Puppy, which I had forgotten about. Some of the really awesome things that as a security researcher he put forth in how that plays into application development, which is kind of interesting. I'd like to get him on for an interview. I don't know if anyone knows what Jeff is up to. That'd be cool. I don't
That
know.
would be awesome. I mean, it's weird to think that SQL injection is 20 years old,
Mm.
right? Or at least according to theories of injection, it dates back to 1998. And so it's an interesting thing to see, especially in that time frame, right? So talking about the whole rise of application security, the only reason that any of this exists is as a result of the ecosystems that have come about from things like the dot-com era, right? So 2001, the OWASP Foundation or the OWASP project was put together. So the reason that that comes together is because of the fact that back then was the huge dot-com boom and bust, where we saw things like Yahoo, Google, Amazon, and a lot of other major players in the space of just technology industries today exist that at the time were just forming. They were just coming into existence. And as a result of that, now, 18 years later, 17 years later, we actually see this whole idea of serverless architecture or cloud or any number of different things that have led to the need for application security, because ultimately it's the applications that are the business. Amazon.com is an application that is making money for the company Amazon, as opposed to your traditional like mom and pop shop sort of things.
What else? You got a couple articles in here. I don't know if you want to briefly describe them before we go on to the next segment, and encourage our listeners and viewers to visit wiki.securityweekly.com, go to Application Security Weekly, and you can find all of the links and notes that we talk about during these shows.
Yeah, so one of the things that I like to talk about here, especially is I put a link in there to Gary McGraw's A Brief History of Security, or excuse me, of Software Security and Software Security as a thing. And he is one of the founders of BSIM. So in this case, that's the Build Security in Maturity model. So as in like put security in the process of development. And inside of that, he talks a lot about how software is effectively eating the world. And also, of course, that at the time anyway, in the whole SDLC model, penetration testing happened right at the end. And let's face it, today with a company that is its entire business model is related to a website, for example, think of maybe like Salesforce. They're not going to pen test right before releasing a feature. And if they are, even if they find things that are bad but not earth-shattering, they're still going to release that feature and go back and fix it later, which in today's world of DevOps, if you're pushing code to production 3 or 4 times a day, that just doesn't work. Ultimately, if you put a pen test at the end, you're not going to stop the feature from being released, period. So I think that's his whole slide deck definitely talks to a point in security that we were maybe 10 years ago, which is we should be testing throughout the process of development and thinking about this at an earlier stage. But because DevOps and Agile exists as it does today, getting there early means just being embedded or being an ambassador into that development cycle itself. So literally sitting alongside those developers, working with them to make sure that they are thinking about security as part of that process of development, and then making sure that you're just kind of injecting those little pieces of security into the thought process. So making sure that when the lock is closed, that the door does not open appropriately, and making sure that the test is built to achieve that sort of state. So other articles in there, though, I did put a couple in there from Checkmarks, which talks about kind of the rise of application security in more modern eras, especially the part 2, which talks about things like bug bounties, which, again, working for BugCrowd is something that's come up in the last 5 years, which has been an interesting change to the traditional pen testing model. And I think that has been given rise to the fact that DevOps is ultimately moving very fast, so you can't afford to have a pen test every week. So instead, people are moving to this pay-for-results model of bug bounty programs. But in addition to that, it also talks about things like the Trustworthy Computing Group or Trustworthy Computing team at Microsoft that was formed back in 2002. And I think that in a lot of ways, that whole idea of having dedicated teams to security, especially in the application side of things, comes about from leadership like what Microsoft has done. But at the end of the day, I like to think about broader topics that led to application security even coming into being. And in the same way that I think that the reduced cost of storage or disk space over time ultimately led to the security incident and event management market existing, because if disk space was still expensive, you wouldn't be able to store all those logs, let alone review them. So in the same way that cloud environments have come into being, in this case, DevOps, or being able to push production quickly with microservices and containerization like Docker, has allowed developers to move faster. And ultimately, because of the dot-com boom, bust, and eventually now, I think we're in another boom again where we have a lot of multi-billion-dollar companies that are almost solely software-based. As a result of all of those things coming together, we see application security becoming more and more important to organizations that are getting off the ground. And instead of offering a product in terms of a device, they're offering a service of some kind, whether it's a platform or software or infrastructure. We see all of those, star AAS monikers that have been thrown about lately. And that's ultimately, I think application security exists because of the fact that companies are moving towards software as a solution for sales. And we even, well, ironically, and we'll talk about this in the news segment, we still see software security being a problem at the hardware level, as with the Intel and supposedly AMD and ARM architectures being vulnerable to a couple of different things that have come out in the news this week.
Awesome. All right. Are we ready to take a break and come back and talk about news and learning and tools?
Sounds good.
All right. Let's do it.
Thank you.
Awesome. All right. Let's jump right into it.
I love this music, by the way.
Yeah, it's great. Perfect. Nailed it.
Thank you.
Yeah, good job, John. Good job with the logo, too.